Hey everybody, today we're trying to show that these two four-digit numbers, and y'all have seen it written in this overline notation. If you have an overline, it makes it real clear. I think most people would interpret this the proper way. But you see, this is a four-digit number, and this is the reverse of the four-digit number. And we're supposed to show that when you sum these two numbers that they're composite. Y'all, and composite is, I guess, a synonym for prime, not prime. That means it contains a divisor between 1 and the number itself. For example, 6 is prime. It's equal to 2 times 3. Okay. So composite and not prime mean the same thing. And just let's do a concrete example to get started, because I've already done most of the work for this one. Let's say 2, 5, 6, 9. And then the reverse of that would be 9, 6, 5, 2, right? Now when you add this, let's see, what do we end up with? This is a 1 at the end here. Carry the power of 10. And you would get what? A 2 here. Carry the power of 10. And you get 2 again. Carry the power of 10 and you get 12. Yeah, there's a pretty well-known divisibility test by 11. If you do 1 and you alternate here, 1 minus 2 plus 2 minus 2 and then plus 1, that's equal to 0. I believe, isn't it? I hope so. I think it is. Yeah, because you got 2 plus 2's and 2 minus 2's. Now notice that any number divides 0, but in particular 11 divides 0. Okay. So what that means is that 11 divides this. Now again, I won't go through this has to do with the fact that 10 raised to the n is congruent to negative 1 raised to the n, mod 11. Okay. That's something that needs to be established, but once you do that, that's why the alternating test works. So in other words, we know that 11 divides the sum, right? So that means that this number, 12,221, is a composite number. It's not prime because it's divisible by something between 1 and itself. It's not relevant that 11 happens to be a prime number, okay? Now, so let's look at the overall proof here, because in this particular case, 11 always divides four-digit numbers summed together in this form. So here's the expressions right here. This is what it means. It's just the Hindu-Arabic expression for ABCD, and then here's the Hindu-Arabic expression for DCBA. Now, when you sum those things up, both A and D have a coefficient of 1,000. And then so on. This is just the algebra associated with this. And notice here that 1,000, and there's a 1 understood right here. So you have A plus D times 1,001. All right, and then right over here you have B plus C times 1,010. Okay. Now we catch a break right here though, because 1,001 by our previous test is divisible by 11. It happens to be 1,001 happens to be equal to 7 times 11 times 13. Not too hard to do in your head. 7 times 11 times 13. And of course 110 is 11 times 10. So just by appearance alone, we're already done with the problem, right? 11. I guess if you wanted to take this, be a little bit more careful with this, you could write this is 11 times A plus D, and we need to know what 7 times 13 is. Is that 91? Okay. Plus, we took 11 out of this, 10 times B plus C. Again, a lot of people would just say proof complete at this stage right here, but this just makes it slightly more complete, I guess, or professional, whatever. Never been accused of being professional. Okay. So you see this we can just say QED here because we have ABCD plus DCBA is equal to 11 times some other integer. Okay, so that means that this sum, which is what we're trying to do, this sum is composite. Because this is clearly a number bigger than 1, right? So we have, this is composite. That does it. There was a problem in Titu Andreescu's 104 number theory problems, but he just did it for 2 digits, which is fairly trivial. It ends up being divisible by 11 also. And it's probably true for any even reversograms or anagrams, or whatever you want to call these things. Okay. So anyway, QED. And of course, we don't know that 11's the only divisor, but all you need is one divisor between 1 and the number itself. And certainly 11 meets that condition here. Okay. So pure talent.